Hello friends, welcome you all on my YouTube channel JK Academy India. In this video, we will talk about the cooling of transformer. So, when a transformer is connected to the mains, heat is produced in the transformer due to various losses. This increases the temperature of the transformer, and the output of the transformer is limited by the rise in temperature. Therefore, some means are provided to cool down the transformer so that the rise in temperature may not go beyond the permissible limits. Mostly, the transformers are designed up to class A of insulation. So, according to specification, the rise in temperature of transformer when working at rated output shall not exceed 45 to 60 degree. Suppose ambient temperature in India is about 50 degrees centigrade in peak summer, and if we take the temperature rise maximum value 60 degrees centigrade, so the transformer temperature may go up to 110 degrees centigrade. So the insulation provided for winding is subjected to a risk, and if the temperature exceeds more due to excess heat, the winding may burnt out, or the core will get heated, or we may see the hot spot in the core, and ultimately the magnetic circuit of the transformer is affected. So most of the electrical machines have rotating part, therefore it is easy to cool down such machines by providing fan on their shaft and ducts in their construction. But in case of transformer, there is no rotating part, therefore it is difficult to cool down the inner parts of the transformer. However, depending upon the size of transformer, various methods have been evolved to dissipate the heat produced inside the transformer, and these are mentioned below. First one is the natural cooling. In natural cooling, three types of cooling is given. One is air natural cooling, second is oil immersed natural cooling called ON, and third is oil immersed forced oil circulation natural cooling. And second is the artificial cooling, in which oil immerses forced oil circulation with air blast cooling, that is called OFB. Second is oil immerses air blast cooling or OB, and third is air blast cooling. In this cooling, fans are provided below the radiators of transformer, so the oil circulating inside the radiator is cooled by the air flowing through it. Artificial cooling of water type oil immerse water cooling, that is called OW, and oil immerse forced oil circulation with water cooling is called OFB. Fourth is the mixed cooling, in which oil immerse natural cooling with alternative additional air blast cooling. Oil immerse natural cooling with alternative additional forced oil circulation called ONOFN. Oil immerse natural cooling with alternative additional forced oil circulation air blast cooling. And fourth is oil immerse natural cooling with alternative additional forced oil circulation and water cooling. So this is the most efficient cooling provided for high rated transformer. In cooling, the major part of heat dissipation is played by the transformer oil. The transformer oil is a mineral oil obtained by fractional distillation of crude petroleum. The oil is used only in the oil-cooled transformer. The oil not only carries the heat produced due to losses in the transformer by convection from the windings and the core to the transformer tank, but also have even more important function of insulation. It also works as insulator. When transformer delivers power, heat is produced due to iron and copper losses in the transformer. This heat must be dissipated effectively, otherwise the temperature of the winding will increase. The rise in temperature further increase the losses. The efficiency of transformer will decrease. As there is no rotating part in the transformer, it is difficult to cool down the transformer as compared to rotating machine. Various methods are adopted to cool down the transformer of different rating. The common method are air natural cooling, oil immerse natural cooling, also called ONAN. Third, oil immerse forced oil circulation cooling, in which pump is provided. Oil immersed forced oil circulation with air blast cooling. Along with the pump, fans are also being provided. And oil immerse forced oil circulation with water cooling means the radiator fins are being cooled by heat exchanger, in which water is flow through pumps. Now, as we are using oil in the transformer, so to uh, maintain the oil level in the transformer up to the top, one tank is being provided over and above the transformer tank, and this tank is called the oil conservator tank. Is also called known as oil expansion chamber. It is a small cylindrical airtight and oil tight vessel. The conservator connected with a tube to the main transformer tank at the tank cover. This tank is partially fitted with oil. The expansion and contraction of oil changes oil level in the conservator. Second part is the breather. The transformer oil should not be allowed to come in contact with the atmospheric air since a small amount of moisture causes a great decrease in the dielectric strength of transformer oil. That is called BDV, breakdown dielectric voltage of the transformer oil, which should be normally more than 40 kV. All the tank fittings are made airtight. When oil level in the oil conservator tank changes due to expansion and contraction of oil because of the changes of oil temperature, air moves in and out of the conservator. This action is known as breathing. That's why this breather is connected through the pipe with this oil conservator tank. The breather is made to pass through an apparatus called the breathed air is made to pass through an apparatus called breather to abstract moisture. Breather contains silica gel or some other drying agent such as calcium chloride CaCl2. This ensures that only dry air enters to the conservator tank or to the transformer tank. Now, last but not least, Buchholz relay. It is an most important part in the power transformer and distribution transformer also. This is installed in between the main tank and the oil conservator. It is a gas relay which gives warning of any fault developing inside the transformer. That is called incipient fault or internal fault. And if the fault is dangerous, the relay disconnects the transformer circuit. This relay is installed in the transformer having capacity more than 750 kVA, and it is mandatory device if the transformer rating is more than 750 kVA. Mostly the Buchholz relay is connected in between the oil conservator tank and the main body of the transformer tank, and one pipe is being connected to transformer. Here in between the conservator tank and the transformer tank, Buchholz relay are installed at an angle of not more than 15 degree. So thanks for watching.